Module 5 continues. Next topic is structural systems. Let's see the development of the structural system. The first structural system was developed in New York. Its name is Park Row Building, which has already reached 30 stories in 1899. So nowadays, a lot of dramatic changes have undergone and many tubular forms have been developed in international style and which has necessitated by the emerging architectural trends in design in conjunction with economic demands and technological developments. The primary structure skeleton of a tall building can be visualized as a vertical cantilever beam with its base fixed in the ground. As you can see from these pictures, these all resemble a cantilever beam which have its strong base at the ground. So these buildings have to carry vertical gravity loads as well as gravity loads means the weight of the dead load of this building and with the live load of the building, that includes the gravity loads, and it also has to resist the lateral loads like wind and earthquakes, and the building must have an adequate shear and bending resistance, and it should not lose its vertical load carrying capacity. So we can see that these buildings may have the column sizes which will increase progressively towards the base of the building in order to resist the gravity loads which are carried from the top floors. Next, structure system classification. The most common structure systems which we see in our country as well as in world includes first one, the bearing wall structures, second one, rigid frame systems, third one, the wall beam structure which includes interspatial and staggered truss systems. Next, we have flat slab buildings, then tubular systems, and then composite buildings. Next, we can just see one by one what are the details of these different systems. First one, the bearing wall structure. The bearing wall structure generally consists of assemblage of linear walls. So it is again divided into two. First one, long wall system. Second one, cross wall system. So what do you mean by this long wall system? Long wall system can be understood better by seeing this picture. You can see that it consists of linear walls which are running all around the building. That is, these walls are parallel to the length of the building. Next, we have cross wall system. So what do you mean by this cross wall system? Cross wall system consists of parallel linear walls which are running perpendicular to the length of the building. So we can see these are the walls which are placed cross to each other, which consist of these cross walls which are placed opposite. We can see that these walls are placed in opposite directions, and it does not interfere with the main facade of the building. Next, here we can see the two-way system. It consists of walls running in both directions. Next, we have rigid frame systems. Rigid frame skeletons generally consist of rectangular grid of horizontal beams and vertical columns. So you can see these are the horizontal beams and we have the vertical columns. So they are forming a grid which are jointed by rigid joints. So the frame may be in plane with an interior wall of the building or in plane with the facade. And the rigid frame seems to be economical up to 30 stories for the steel frames and it is economical only up to 20 stories for the concrete frames. The strengths of individual columns and beams decide the load carrying capacity of the frame. Next comes the wall beam structure, which can be either interspatial or staggered truss systems. So one by one, we can discuss first one, interspatial systems. In interspatial system, trusses are used at every alternate floors. It can be explained with this figure. You can see this is a tall building, and we can see the truss members are placed in alternate floors in order to give a better appearance to the building, and it requires flexibility in planning. Here also we can see the same interspatial system with the truss members arranged in the alternative floors. Next comes the staggered truss. The staggered truss building is much stiffer than the interspatial system, because here you can see the picture. This is more, what we can say, this more stiffer or stronger than that of the interspatial system, because we can see the truss members in every floors which are not arranged or planned in a beautiful manner, but it gives more strength than that of the interspatial system. And the floor slabs rest on the top chord of one truss, as we can see here, hang from the bottom chord of the next on the floor above. So this is much more stiffer and much more preferred than that of the interspatial system. Next comes the flat slab building structures. Flat slab system does not need any floor framing, as it consists of solid or waffle type slabs supported directly on the columns. So flat slab means there will be no beams present in that type of structure. Only slab will be present, and the slab will be of thicker size than that of a normal slab. And the maximum story height is increased as a result of this. So in order to give strength to this construction, drop panels or column capitals are frequently used, because there are shear failure at the concentration of at the junction, not the concentration, at the junctions of the columns and slabs. Slabs without drop panels are known as flat plates. So one can visualize that a portion of slab will act as a shallow beam which is continuous with the columns, thus behaving as a rigid frame. The lateral forces are resisted by the frame action in the upper portion of the structure and by the shear work or core wash system in the lower portion. So it is better explained, it can be better explained by these figures. So we can see that this is a flat slab construction. It has a great room height. A great room height is achieved by using this flat slab system, as there is no beams present in that system. And we can see these all are the flat slab building. You can see only the slab is there, which is supported directly on the columns. So in order to give more strength to the flat slab construction, at the junctions of columns and beams, small panels are provided. Like these are known as drop panels. If it is made thicker, it is known as column head. Here we can see that column head and drop panels are provided along with the slabs. So accordingly, we can classify the flat slab into various systems. Next comes the tubular systems. The amount of structural materials used per square foot of floor space in tubular system is half that of that used in the conventional frame buildings, hence it is very efficient. Next, tubular designs assumes that the facade structure responds to lateral loads as a closed hollow box beam cantilever out of the ground. Just we can see that you can see a small figure representing a tubular structure. Nothing but it looks the building may look like a tube, and the whole arrangement, whole floors, etc., will be arranged inside the tubular structure, and it may have closely spaced columns around the perimeter of the building and tied together by spandrel beams, means thicker beams. The stiffness of the facade wall may be further increased by adding some braces. We can see that in order to increase the stiffness of the building, some steel bracings may be provided all around the structure. Hence, the rigidity of the tube is so high to resist the lateral loading, even if it is similar to cantilever beam. Next comes the composite beams. Composite buildings may consist of two materials which will act together as a structural unit. Namely, it may be concrete or may be made up of some high carbonated steels. This is made that for increasing the lateral stiffness of framed skyscrapers. So in order to design this building, two methods are used. First one, tubular composite buildings. Exterior steel. What it means is that the exterior steel frame is stiffened against lateral deformation by a casting place concrete perforated perimeter wall. That is, a concrete structure is formed and and the steel frames are stiffened against lateral deformation all along the perimeter of this concrete wall. The resulting sway of the building resembles that the rigid tube cantilever out of the ground. This approach combines the fast erection and high strength. There is interior space flexibility, lateral rigidity, and moldability of the concrete curtain wall. Next comes the plate wall cladding. That is, curtain walls of panels are usually attached to the steel frame structures. There will be steel frames, that is, the main structure may be built up of steels and it may be surrounded with some panels which may be either made of reinforced concrete or some other useful materials. It provides weatherproofing, window framing, and we can give desired architectural expression, but it may also have some structural stiffness. The composite action of the steel skin and concrete steel frame improves the lateral resistance so much that the interior girders needs less stiffness. The sway of the building constructed by this method can be reduced up to 20 to 50%. What I mean by sway is the, the building may be deformed to one side, either left or right. That is known as swaying of the building. So this is considerably reduced by using this method because the steel frames are itself very strong. When it is combined with some other panels, maybe either made of wood or concrete, it will considerably reduce the sway of the building.